What is serialization and deserialization? Okay, let's look at this. We have already discussed this, that usually we have a client. Let's say we have this client. It's a browser, all right? It's a browser. Let's say it's Chrome. And this is called front end, right? In our typical technical language. And usually we communicate with a server that's running in your local host, or it's running somewhere remote in cloud, in AWS or GCP or Azure, anywhere. And the client communicates with the server through some means of network communication. It can be through HTTP, right? Our traditional REST API endpoints, or it can be through gRPC, or it can be through WebSocket. We have different means of communications for clients and servers to communicate with each other. For this example, and throughout this series, since we are focusing on HTTP or our traditional REST API style communication, let's assume this client is a JavaScript app. It can be a React or Angular or Vue, any JavaScript framework or library. It's a JavaScript app. Usually most of the client-side apps are built with JavaScript, highly interactive apps. In order to send a request to the server, the client has to make an HTTP request, which we have already discussed in the previous videos. Looks something like this: get, etc., etc., the URL, the HTTP, right? Some domain.com/path, something like this. So either a get request, or if it's a post request, we have the URL, and below we have the headers, and below that we have the request body. And this is how frontend sends the data, the request, with all the information that is required or the client wants to send to the server. Right? This is how client sends information to the server, and the server responds with some response which the client is able to pass and make sense of. So the thing to notice here and the thing to focus here in this chapter or in this session is how clients and servers can make sense of the data that is being received or the data that is being sent. For example, in our case, the client is a JavaScript app and the server can be a Rust app, right? The web server is built with Rust language. So in JavaScript, let's say we are sending this object, right? And we have name is some string. We are sending this. And after we send this in the request body and it reaches the server, which is a Rust server, how does the server take this data and is able to make sense of it? It is able to make sense of it in its own format, in its own data types, because JavaScript and Rust have completely different data types. JavaScript is a completely dynamic language. It is not compiled. On the other side, Rust is very strict when it comes to types, and it is a compiled language. All the data types are completely different from JavaScript. So how does this happen? How one data type that is transmitted over a network is able to reach another machine that is somewhere else in the internet, and it is able to make sense of that data and perform some business logic and send some response, and the client is again able to make sense of that response and able to show some UI or perform some business logic. How does this all come together? So before we talk about data transmission over the internet, it's very good to have some knowledge about OSI model. If you're a CS student, you might have already come across it. If you're not, then you don't have to completely master it or understand every aspect of it, like IP packets or data frames, etc., etc. But having a good high-level overview or a high-level understanding of how these OSI layers, different layers of network, communicate with each other over the internet to transmit some kind of data over hardware, right? We have different types of layers called application layers and network layers, right? There are a lot of good resources in YouTube or any other platform that you can look up and just get a high level understanding of OSI model. And going too deep into this is out of scope for this video and will probably take too much time, and people who are way better than me have explained this in a way better format. And now, assuming you have a high level understanding of OSI models or just are aware of what this model is and how it helps make sense of data transmission over the internet. Now, the layer on top is called application layer, and after all the layers, the bottom layer is called physical layer, or you can call it top, call it bottom, does not matter, right? These two are in the opposite end of each other, right? And the same thing happens on the server side. Here in the server we have application layer, and in the bottom here physical layer, and there are layers in between. Now imagine if you were asked to solve this problem, the problem that we have two machines that are in different locations and they are connected over the internet, right? Let's say over the cloud. And you were asked, you have to come up with some way or some technique or some protocol, to go with the technical terminology. You have to come up with a way so that clients or one machine is able to send data to another machine, and they should be able to parse the data and make sense of it in a way that it is language agnostic. And a very obvious and common solution that you might come up with is figuring out a common standard, which is just a fancy way of saying you will come up with some set of rules and you will ask both the clients and the server to agree that this is the standard or this is the format that the client should send the data in, or the server should send the response in, so that client does what it needs to do during the execution of the session of the user. And when sending data to the server, it transforms or converts whatever the logic is from that language, let's say from JavaScript, to this standard, this format, and sends it over the network. And when receiving, the server takes the data from that standard and converts it into its own standard. Let's say it's Rust. So it converts it into a struct in Rust, and it understands the data format and whatever it needs to do. And when sending the response, it converts that data, let's say from a Rust struct, into this standard, this common format, and sends it over the internet. And again, the client reads it and parses it into JavaScript, and it's able to do whatever it needs to do. This part. This is the solution. What is the solution? The solution is coming up with a serialization standard. Common standard that the both client and the server agree to send and receive data. And to summarize this whole thing, serialization and deserialization is basically converting to and from data to a common format, so that during transmission or storage, we'll get to the storage part, but from this example, we can say that serialization and deserialization is basically converting data from and to a common format while transmission, so that it is domain agnostic, or in this case, language agnostic, so that machines and servers and clients from different domains and different languages from different environments are able to make sense of that data and are able to respond to that data. And before we dive deep into the serialization standard, I just want to make a note here that, which I have already mentioned, that backend is a huge domain, and there are a lot of technologies, hundreds of technologies that is used in the industry. So it's impossible to understand the concepts behind all of those technologies. What we will do in this video and in this whole playlist is we'll go with the most used technologies. For example, for the data transmission, there are a lot of technologies getting used. For example, HTTP and WebSockets, and you have gRPC, etc., etc. So we'll go with HTTP since REST APIs are still the most common means of communication over the internet between clients and servers. And as a backend engineer, if you are aware of and have good experience in HTTP, then you're good to go. You can learn all these other technologies along the way. You just need something which is used all of the industry to get started and get some experience, and you can learn technologies as you progress over your career. In the same way, for databases, we have a lot of different types of databases. We have relational, right? We have non-relational. In relational, we have Postgres, we have MySQL, we have SQLite, right? Same way in non-relational, we have MongoDB, we have DynamoDB from AWS. A lot of different options for databases, but in this playlist, we'll go with Postgres, right? It's one of the most popular relational databases and it is used by a lot of companies and mostly the first choice these days for a lot of startups and enterprise servers. In the same way, we have different types of serialization standards. Serialization standards. And we will go with a popular one, the one that gets used. I won't give a number, but if I had to give a number, I'll say 80% of the time, which is JSON. Is one of the most popular serialization and deserialization standards that gets used for client and server communication. We have other standards for serialization, deserialization that does not necessarily gets used for HTTP communication, but definitely gets used for serialization. For example, we have YAML, we have XML, and inside serialization standards, these three, including JSON and XML, YAML, these things are called text-based serialization, right? We have another type of serialization standard, which is called binary format. Binary format, and in binary format we have all again different types, and the most popular one is called protobuf. We have other formats also like AVRO, etc., etc. For serialization standards, we have text-based and binary format, and inside text-based we have different types called JSON, YAML, XML, and for now we will only focus on JSON since that's the most popular choice for HTTP based communication between clients and servers. Now that's clear. Let's jump into JSON. And this is what a typical JSON object looks like. So to give you a little context, JSON stands for JavaScript Object Notation, and you can read more about JSON's history and its evolution from other resources. But just to give an idea, JSON from the looks of it and from the behavior looks very similar to a JavaScript object, right? And that's why you can understand why it's named like that, JavaScript Object Notation. But it is not limited to JavaScript and it is used everywhere. You will find JSON in configuration files, and of course during HTTP REST API transmission between clients and servers, you will find JSON in log files. JSON is a very popular choice for logging application data or server data during runtime. It has a lot of use cases. For this use case, we are going to focus on HTTP transmission, of course. This is what a typical JSON looks like. From the looks of it, you can understand it's completely human readable, and that is one of the strong points of JSON. It was made to be human readable, and the data types are also pretty fundamental if you are even a little familiar with different programming concepts. For example, things to focus here is we have a starting curly braces and an ending one, and all the keys are inside double quotes. So this is one rule you have to follow. The keys will be inside double quotes and they will be strings. You cannot make any other data type as a key. Keys will be inside double quotes and there will be strings, and in the value it can be a string, or it can be a number, it can be a boolean, or it can be an array, or it can be another object, right? JSON can be a nested object also. For example, let's say you have here an address field. inside the same JSON. You have a colon here, and you can start another curly braces. Here you can write country. You can say it's a string, it's India, and your phone number, right? Phone number. And it can be a number, something 3, 4, 5, 6. And you have to provide an ending curly braces. Right? This is the typical structure of JSON. That's all there is to it. You won't find a lot of concepts in JSON. These are the things you have to remember. There has to be an starting curly braces and an ending curly braces. And the keys will have to be inside double quotes, and there will be strings. And in the value, you can provide a string, a number, a boolean, or an array, or a nested object, which will again have the same characteristics of the initial object, right? There'll be keys which will be inside double quotes, and there'll be strings, and they will have values again in the same characteristics. So that's all you need to know about JSON. This is one of the most popular serialization standard that we use during client and server communication. So let's just see a simple demo. In fact, let's just see our earlier demo that we saw in the previous video. And this time we'll focus on the request and response format, the serialization and deserialization format, and see how it looks like. Pretty much looks like the same thing that we saw here, but let's just see in a real environment. Okay, here we have our Burp Suite interface, and this is the earlier demo that we saw in our previous video. But this time we'll hit an API and focus on the data format that gets transmitted and the data format that gets received from the client and from the server. So let's just hit the post API that was here, post books, and let's go to HTTP history and open this one. And let's expand this and go to the request and response. This is a post request, and we are calling this path API/books. This is the data that we are sending. So let's just focus on the request first. Here we can see our earlier discussed JSON format. We have a curly braces, and we have all the keys that are double quoted, and those are strings, and we have a number here and 2 strings like ID, title, and author. This thing gets transmitted over the network. Now, one thing that I want to mention here is, if you went deep into the OSI model, so you must have come across that from application layer to it gets converted into data frames and etc. etc. It gets converted into IP packets, and there is transmission layer, and in the end it gets converted into bits with 0, 1, 0, 1 stuff, network related stuff, right? So as a backend engineer, the thing you have to focus here is the mental model you should have is, you can assume that you have this client and you have this server, right? The client has to adhere to a particular standard. Let's say this is JSON, and the server has to understand this standard called JSON. We transmit this, the server understands this and returns some data again in JSON format. With respect to your knowledge of OSI model, which has different layers, which the data gets converted into different formats, from data frames to IP packets to physical bits that gets transmitted with voltage signals over optical fiber, etc. etc. The mental model to have is, in application layer gets converted into JSON. As a backend engineer, that's all your responsibility is. It does not matter what format it gets converted into after this point. That is not of your concern. So it gets converted into different formats, and then in the end 0101, and then again it reaches the server, reaches 0101, etc. reads all the bits and does all the network related stuff. Then it again gets converted into JSON only. In the server side also, does not matter what the intermediary steps convert the data into. That does not matter. Before in the receiving end of the server, the data again gets converted into this JSON format only, and the server only gets to read the JSON. So you don't have to worry about all the intermediary steps. Now that's clear. This is the request JSON that the client sends, and the server understands this, and it takes this ID and all this information and adds it here and responds with another JSON, right? It's another JSON. So again, we have the opening curly brace and ending curly brace. We have one key, which is an array, and each array has an object. Again, it is also in JSON format. You can see all the keys are in double quotes, and it has values in number and string formats. And this is an array, and it's received by the client, and the client understands it. And if you see here, we are rendering it here. So the client is able to receive this data from the server, and it is able to make sense of it. It is able to parse it, and it is able to render it in its own way, right? In this case, it is JavaScript, but it can be PHP also, etc., etc., right? This is how JSON flow looks like in client server model. In real life scenarios, it does not have a lot of concepts. Serialization and deserialization do not have a lot of concepts. It is a phenomena in the backend world that exists. You have to know that it exists, and JSON getting transmitted by the client to the server parsing it, understanding it, making sense of it, and responding with appropriate data to the client, and again the client parsing it, understanding it, making sense of it. This whole flow is called serialization and deserialization. So again, to summarize, serialization and deserialization are the techniques using which data is converted into a common format, a standard format, so that clients can send data to the server in that format, and the servers can receive that data, make sense of it, parse it, and perform the business logic and send the data again in that common format, so that the client can again do the same thing. Serialization and deserialization are basically dealing with standard format so that data is understandable across domains and language. That's all there is to it in serialization and deserialization.